China frustrated, its flagship VT4 tank suffers a barrel explosion, raising serious questions about manufacturing quality. The quality of China's defense industry, particularly in the main battle tank sector, has once again come under scrutiny. This follows reports of an explosion in the main gun barrel of a VT4 tank operated by the Royal Thai Army during its use in confronting Cambodia. The incident has reignited fundamental questions regarding manufacturing quality, material standards, and the operational durability of one of China's flagship defense products. Although Thai authorities have not yet issued an official statement, visual evidence circulating on social media shows severe damage to the muzzle of the 125mm gun barrel, strongly suggesting a structural failure while the projectile was still inside the barrel. The VT4, also known as the MBT-3000 or Main Battle Tank 3000, is a new generation tank produced by Norinco of China, marketed as a comprehensive package featuring modern technology, high protection levels, adequate mobility, and more advanced weapon system integration compared to its predecessors. For Thailand, this platform symbolized the modernization of its armored forces after experiencing supply problems with Ukraine's Oplot main battle tanks in previous years. Significant investment was made to procure the VT4 in substantial numbers, with the platform intended to strengthen the Royal Thai Army amid rising geopolitical tensions and evolving regional dynamics. However, a tank's reputation is not built solely on its theoretical combat capabilities, but on its real-world performance. It is precisely here that reports of an exploding barrel deliver a serious blow. If reports of this latest incident are accurate, the VT4 once again finds itself under intense scrutiny. The situation revives long-standing debates over quality control at Norinco's factories, particularly in the manufacturing process of tank gun barrels. The barrel is among the most critical and sensitive components of a main battle tank. Technically, a tank gun barrel must withstand enormous internal pressures, reaching hundreds of megapascals, alongside extreme temperatures generated by propellant explosions and projectile friction. The metallurgical process required to produce such a barrel involves far more than simply using high-quality steel. It includes how the steel is treated, forged, heat-treated, lined, and repeatedly tested. Even minor errors in carbon ratios, chromium, nickel, or other alloy compositions can significantly reduce material strength. Likewise, small imperfections in forging can create microscopic cracks that are initially invisible, but gradually propagate with each firing. In the case of the VT4, reports indicate that its 125mm gun barrel features an internal chromium lining intended to reduce wear and extend barrel life. However, while beneficial, chromium lining also has inherent weaknesses. If the lining cracks, peels, or suffers micro-corrosion, high temperature and high pressure gases from firing will directly erode the underlying steel. Such erosion can accelerate the formation of weak points within the barrel structure. Under certain conditions, such as extremely high internal temperatures combined with gas pressures exceeding tolerance limits, the barrel may rupture or explode. The risk of catastrophic failure increases further if the projectile behaves abnormally, for example, if it momentarily jams or if the propellant generates higher than intended pressure. Another frequently cited factor in barrel failure is extreme operational stress caused by a high rate of fire over a short period. No matter how advanced a modern tank's design may be, metal still has physical limits. Each shot dramatically increases barrel temperature. If a tank crew forces consecutive firing without sufficient cooling intervals, barrel temperatures can reach to the point where the steel begins to lose its strength characteristics. Once the material weakens, subsequent shots become highly dangerous, as gas pressures that would normally be tolerable may exceed the reduced structural limits of the overheated barrel. In such scenarios, barrel explosions become a very real possibility. Intense military training or high-pressure operational situations often create conditions where crews fire repeatedly without accounting for thermal limits, particularly if standard operating procedures regarding firing intervals are not strictly followed. Ammunition quality is also frequently a contributing factor. Defective propellant, inconsistent explosive energy, or unstable projectile travel caused by production issues, storage humidity, or logistical problems can lead to unexpected spikes in internal pressure. In the tank warfare domain, a single overpressure event can destroy a barrel, even when high-quality steel is used. China is known to produce ammunition with varying quality levels depending on production batches and export lines. Consequently, it is reasonable to question whether the ammunition used by the Royal Thai Army met the highest standards or merely fell within the category of being adequately acceptable. If the issue indeed originates from manufacturing quality, Norinco would face serious reputational consequences. In recent years, China has aggressively showcased the VT4 to developing countries across Asia, Africa, and the Middle East as a more affordable alternative to Western and Russian tanks. Thailand is the largest VT4 operator in Southeast Asia, and the success of this program serves as a marketing showcase for Norinco. Therefore, if 2 or more barrel explosions were to occur within the same user's fleet, other potential buyers would inevitably question the manufacturer's quality standards. In the highly competitive global arms market, reputation is paramount. A single incident may be dismissed as an operational accident, but multiple incidents can be interpreted as evidence of poor quality or design failure. For the Royal Thai Army itself, such reports can negatively affect morale and crew confidence. Tank operations require not only technical proficiency, but also full confidence that the vehicle will protect its crew rather than endanger them. Crews who are aware of the possibility of spontaneous barrel explosions are more likely to operate defensively and hesitate during missions. This type of psychological effect is extremely dangerous, as it can undermine combat readiness and overall unit effectiveness. Furthermore, the incident could generate internal political pressure on the Thai government, particularly regarding procurement policies favoring Chinese-made defense equipment, policies that have already faced criticism from segments of the political opposition. A deeper analysis must also consider the possibility that such incidents are not solely the result of tank quality, but also of operational procedures. Crews may have fired at excessive rates without allowing sufficient cooling intervals, used mixed ammunition from different production batches, or failed to conduct regular barrel inspections as recommended by the manufacturer. Nevertheless, many observers argue that even under suboptimal operational conditions, a modern tank gun should possess sufficient tolerance to prevent catastrophic failure from high firing rates alone. From this perspective, the issue ultimately returns to production quality. Another question that arises is whether VT4 tanks exported to Thailand truly share identical specifications with those used by the Chinese military. Within the defense industry, it is not uncommon for export variants to be of slightly lower quality than domestic versions, although China consistently denies such practices and claims that all export products undergo rigorous testing. The explosion of a VT4 barrel also carries geopolitical implications. China has sought to expand its military influence in Southeast Asia through the export of various weapons platforms. Thailand is among the countries with relatively close military cooperation with Beijing. As a result, any failure of Chinese-made equipment risks weakening the narrative surrounding the effectiveness of China's defense industry, while simultaneously creating opportunities for competitors such as South Korea and Turkey. Within the regional security environment, Thailand requires reliable tank platforms to address potential limited border conflicts and maintain internal stability. If the VT4 is perceived as unsafe, discussions regarding replacement or usage restrictions may emerge. Such outcomes would represent a serious setback for Norinco, as tank export programs are a key symbol of China's defense industry success, especially after expressions of interest from countries such as Pakistan, Laos, and Nigeria, among others. Ultimately, the VT4 barrel explosion incident cannot be viewed merely as a technical malfunction. It touches on far broader issues, including China's manufacturing quality standards, material testing methods, levels of metallurgical expertise, user operational discipline, and the increasingly competitive dynamics of the global arms market. If Thailand can demonstrate that the problem stems from quality failures at Norinco, the impact will extend far beyond a single technical incident. Conversely, if China fails to provide a convincing response, skepticism towards Chinese defense products will grow systematically. This incident also serves as a reminder that modern military technology cannot be judged solely by brochures and promotional videos. It is performance in real operational conditions that ultimately determines whether a platform is truly capable of withstanding the extreme demands of combat.